trigonometric functions, exercise 3.2, question number 5. In this exercise, you have to use sine rule, cos rule and projection rule. So you have to remember the three formulas of sine rule, cos, and different forms of sine rule, cos rule and projection rule. So you have to remember properly that three formulas and you have to apply here. So question number 5 is, with usual notations, prove that 2 into a sine square c by 2 plus c into sine square a by 2 is equal to a minus b plus c. Now first we will write and take LHS. Now see here, sine square c, here you have to use sine square c by 2 formula. Now we know formula. See, cos 2 theta is equal to 1 minus 2 sine square theta. You have to remember the trigonometric formulas also. Cos 2 theta is equal to 1 minus 2 sine square theta. This 2 sine square theta will take to left hand side. It will become 2 sine square theta is equal to 1 minus cos 2 theta, take to right hand side. Now this 2 again you will take it down. Sine square theta is equal to 1 minus cos 2 theta upon 2. Now here we want c by 2, means half angle we want. So sine square means we will do here theta by 2. Sine square theta by 2 is equal to 1 minus cos theta upon 2, means this 2 will get cancelled, and 1 minus cos theta upon 2. So we got the formula sine square theta by 2 is equal to 1 minus cos theta by 2. Now here both cos are there, we will use that formula. Only the angle C is there and angle A is there. Now 2 into A, sine square c by 2 becomes 1 minus, according to this, 1 minus cos c upon 2 plus c into 1 minus cos A upon 2. Okay, now this denominator is same, so you can add it and cancel this 2, and this 2 will get cancelled. Now open the bracket, A minus A into cos c plus c minus c into cos A. Now we got A minus A cos c plus c minus c cos A. Now adjust the term A plus c, write it this side, minus, from though both are having minus sign, take minus common and write in the bracket c cos A plus A cos c. Now what is our projection rule? Projection rule is B's formula. C, B is equal to A cos A plus A cos C, which is same. So we will write A plus C minus B, and that only we have to prove, that is equal to RHS. Hence proved. So for solving this type of sums, you should know the formulas: sine rule, cos rule and projection rule. Next one, question number 6. The question number 6 is, in triangle ABC, prove that A cube sine B minus C plus B cube sine C minus A plus C cube sine A minus B is equal to 0. Now here we will take separate, means this we will find separately, this we will find separately, and this we will find separately. So first we will write and take A cube sine B minus C is equal to. Okay, so here we can use, first simplify this and take B minus C, sine B minus C's formula. A cube is equal to sine B, see here minus sign is there, so sine B minus C is sine B cos C minus cos B sine C. Okay, next, now here sine is there, there we will use sine rule. Here two signs are there, there we will use sine rule, and here cos rules, cos and here also cos. So first sine rule is, by sine rule, sine A upon A is equal to sine B upon B is equal to sine C upon C is equal to K. So from this we can write the value of sine A, sine B and sine C. So sine A is equal to, see, sine A upon A is equal to K. sin b upon b is equal to k, and sin c upon c is equal to k. So we can write it separately. Sin a is equal to ak, sin b is equal to bk, and sin c is equal to ck. Now by cosine rule, because here cos c is there and cos b is there, so by cosine rule, b square is equal to, see like this way, how we have remember, see a b c in the cyclic way and c. So b square is equal to, if we want to write formula for b square is equal to c square plus a square minus 2ca cos, here b is there, so cos b. In this way I told you to remember. See, cyclic way, suppose we want to write a formula of b square is equal to c square plus a square minus 2ca cos b. So from this, how we can write, we want cos b and cos c, so how we will write c? So therefore cos b we want, so take this to that side, therefore cos b is equal to c square plus a square minus b square upon 2ca. This also we can remember by the same way. See, here b is there, after b what come, we want formula for cos b, after b what comes, c square plus a square minus b square upon 2ca, modification of this formula only. And in the same way we can write c cos c, a square plus b square, after c comes, again comes a, so a square plus b square minus c square upon 2 and this to a b. So now we got cos b and cos c, and sin a, sin b, sin c. Now write down a cube into sin bc. Now a cube as it is, sin b minus c, formula is sin b cos c minus cos b sin c. We have written it first. Now a cube into, now what is our sin b? bk, and cos c is, see how to remember cos c, a square plus b square minus c square upon 2ab, minus our cos b is c square plus cos b, after b what comes, c square plus a square minus b square upon 2ca into, so now cos b formula, c square plus a square minus b square upon 2ca into sin c is ck. Now from here we can cancel b and b, and here we can cancel c and c. Now what is common here? 2a is also, 1 upon 2a is common, and k is common, take it outside. So inside what remains? A square plus b square minus c square minus c square minus, change the sign, minus a square plus b square. Now here this a and this, from this 1a cancel, so a square k upon 2, and a square gets cancelled, okay, a square gets cancelled. What remains? 2b square minus 2c square. From this take 2 common, so here 2 gets cancelled, and a square k remains b square minus c square. So whatever value came, a square sin b minus c is equal to a square k into bracket b square minus c square. In the same way, in the sum c second term is b cube sin c minus a. Now see here a, in the same way we can write, no need to solve again, the sum will become big. So here a square is there, then we have written here a square, a cube is there, here a square, k is everywhere common, k, and here b minus c is there, so b square minus c square. In the same way we will write here b cube is there, so we will write here b square k, and here c minus a is there, therefore c square minus a square. Here c cube is there, so here c square k, and here a minus b is there, so a square minus b square. In the means first you will solve and then you will write in the same way this for two terms also we can write. Now this 3 you have to add. What is LHS? Addition of these 3. So we have added this 1, 2 and this 3. Now from this take k common. After taking k common, open the bracket. A square b, multiply a square b square minus a square c square plus b square c square minus b square a square plus c square a square minus c square b square. Now see what get cancelled. Each term gets cancelled, so k into 0 is 0. So we want to prove that only, that LHS RHS is equal to 0. Next sum, 7th sum. The 7th sum is in triangle ABC, if cot A, cot B, cot C are in AP, show that A square, B square, C square are also in AP. Now here these three, cot A, cot B and cot C are they are in AP. So what is the condition for AP? If the 3 terms are in AP, we can write middle term cot B is equal to first term plus last term divided by 2. So cot B is equal to cot A plus cot C upon 2. Now take this to this side. 2 cot B is equal, and you have to prove that A square, B square, C square means sides. Here angles are there, these are the sides. They are also in AP. So take this to this side. 2 cot B is equal to cot A plus cot C. Now how can we write cot? Cos upon sin. So 2 cos B upon this 2 as it is. Cot B means cos B upon sin B. Cot A means cos A upon sin A. Cot C means cos C upon sin C. Now this keep as it is. Here do cross multiplication. Cos A sin C plus sin A cos C upon sin A into sin C. Now we will adjust them. This term write it first. Sin A cos B plus cos A sin C upon sin A sin C. Now see, this is the formula for sin A plus C. So this left hand side as it is. This is the formula for sin A plus C. So middle plus sign is there. Sin A plus C and upon sin A sin C as it is. Now first only we have seen how to write A plus C. A plus B plus C is equal to pi. Addition of angle of sum of angle of triangle is pi. So we want here A plus C. So A plus C is equal to pi minus B. Substitute here. A plus C means pi minus B upon sin A sin C. Now 2 cos B sin B is equal to sin B into sin A into sin C. Now this sin B will take this side. It will become sin B into sin B is sin square B upon sin A into sin C. Now here sin is there and cos value is there. So we will again use sin rule and cos rule. So what is our sin rule? Sin A upon A is equal to sin B upon B is equal to sin C upon C is equal to K. Sin A is equal to AK, sin B is equal to BK and sin C is equal to CK. And again cosine rule. So here we need here cos B. So we will use of B square formula. B square is equal to, again the cyclic way, B square is equal to C square. After B what comes? C square plus A square minus 2CA and cos this B. Using that we can write cos B is equal to C square plus A square minus B square upon 2CA. Now we'll substitute in this equation number 1. See, now from 1 substitute the values of sin and cos. So you will get here 2. See here 2 cos B. 2, this is cos B is equal to B square K square upon AK into CK. So now this 2 gets cancelled. This K and K and this K square get cancelled. This CA and this CA gets cancelled. So what we get? C square plus A square minus B square is equal to B square. Now C square plus A square is equal to this B square will take this side, it will become 2B square. C square plus A square is equal to 2B square, therefore B square is equal to C square plus A square upon this 2, take this side upon 2. So now see here, we have proved B square is equal to C square plus A square upon 2, therefore A square, B square plus C square are in AP. We have satisfied the condition for showing that they are in AP. Hence, proved. Now, see question number 8. In triangle ABC, if A cos A is equal to B cos B, prove that triangle is a right angle or an isosceles triangle. So, right angle means you have to prove that one angle is 90 degrees. So, see here A is there and here B is there. So first we will write the sine rule for writing the values of A and B. Therefore sine rule, A upon sine A is equal to B upon sine B is equal to K. Therefore A is equal to K sine A and B is equal to K sine B. Now write down the given condition. A cos A is equal to B cos B. Now instead of A we will write K sine A, this cos A as it is equal to what is our B? K sine B into cos B. Now this K will get cancelled. Multiply both sides by 2 means 2 sine A cos A is equal to 2 sine B cos B. This is the formula for sine 2A and this is the formula for sine 2B. So this is sine 2A is equal to sine 2B. Now take this side, sine 2A minus sine 2B is equal to 0. Now here we will use the factorization formula, that is sine 2A minus sine 2B is 2 cos 2A plus 2B upon 2. Say factorization formula of 11th standard, 2 cos 2A plus 2B upon 2 into sine 2A minus 2B upon 2 is equal to 0. This is a factorization formula. Now this 2 will take this side, it will become 0, and cos, take this 2 common here. So 2A plus B upon 2 will get cancelled into sine, same, to take 2 common, it will cancel, A minus B is equal to 0. Again, here we can write, again A plus B we can write, see A plus B plus C is equal to pi. Therefore A plus B is equal to pi minus C. Therefore cos pi minus C into this sine A minus B is equal to 0. Now cos pi minus C, cos pi minus C means pi means 90, pi minus C means it will come in second quadrant. So in second quadrant, see that how to remember, all students take coffee, all student, S will come in second quadrant. So in second quadrant sine and cosec are positive, other all are negative. So here cos is negative, so we will write minus cos C into sine A minus B is equal to 0. Therefore cos C is equal to 0 or sine A minus B is equal to 0. Now when the cos value will be 0, add cos pi by 2. So cos pi by 2 is equal to 0, therefore C is equal to pi by 2. So when C is pi by 2 means 90 degree, then it is a right angle triangle. So we have proved angle C is equal to pi by 2, therefore the triangle is a right angle triangle. Now see here, sin A minus B is equal to 0. So at sin 0, the value of sin 0 is 0. Therefore A minus B is equal to 0. Therefore A is equal to B. Therefore angle A is equal to B. Therefore the given triangle is isosceles triangle. So both we have proved that. First we have proved that it pi by 2 means it came 90 degrees. So it is a right angle triangle, and angle A is equal to B. From that we can say that a triangle is isosceles triangle. Now see the last sum from that exercise. 10th, 11th and 12th sum is deleted from this exercise. So see the 9th sum. By usual notations, prove that 2 into bracket BC cos A plus AC cos B plus AB cos C is equal to A square plus B square plus C square. Clearly we have to use here cosine rule. So by the cosine rule, 2 BC as it is, cos A, how you will write cos A? After A what comes? B square plus C square minus A square upon 2 BC. Same. AC as it is. Now here B, cos B is there. After B what comes? C square plus A square minus B square upon 2CA. Now here cos C is there. AB as it is. After C what comes? A square plus B square minus C square. Third term minus upon 2AB. Now from here, this BC gets cancelled, AC gets cancelled, AB gets cancelled. This 2 is there and this 2 take it common. So 2 upon 2 which get cancelled, and write down these terms. B square plus C square minus A square plus C square plus A square minus B square plus A square plus B square minus C square. Say which terms gets cancelled. So here A square, C square, B square gets cancelled 1. So what remains? This also 1. So B square plus C square plus A square remains. So that is adjusted term A square, that is equal to A square plus B square plus C square, that is equal to RHS. Hence proved. So simply say, by saying only you understand that here you have to use the cosine rule. Remember the formulas: sine rule, cos rule and projection rule. Applications of the sine rule, cos rule and projection rules are deleted from your syllabus.